Hi again. It's now time to talk about what we use to mark out parts that we're going to be manually manufacturing. As you can see in front of me, I've got a variety of tools. We'll start with the easy ones, I think. This is a rule, a 12-inch rule, not to be confused with a stationary ruler, or a steel rule, it's often known. Simply scale, metric scale on one side, imperial scale on the other side. The difference between this and a stationary ruler is that at the end there isn't a margin, a gap. So that means that the base of this is a 0, a datum point. So it would be simply to measure, say measuring this block, place it on a flat surface, go down, and then I can read what the height is. Steel rule. Most of the technicians here you'll find have one in their pocket. It's a 6-inch one. It's a 12-inch. We all work in metric now, but the names have kind of stuck with us. Next thing we have is these. Looks a little bit like a pair of compasses. They're known as spring dividers, simply because there's a spring at the end here, as you can see. And the way these are used, you get your desired size on a rule. There we go, and tighten it up, like so. And you can now, if I'm going to mark on this little component, you can now mark either circles, so, or you can do equal spacing. So it's there, and then we pivot around that point, another mark, and so on. Spring dividers. Next, this is a square, or a set square. It's got 2 parts. It's got a blade and a handle. It's exactly 90 degrees on the outside and on the inside. So this is used for marking perpendicular lines. Again, if I wanted perpendicular lines from this edge, sort of on there, and then scribe up the side. And it's also used for measuring corners. So I can see that this is pretty close to 90 degrees. Set square. After that, we have this, which is called a punch, or a center punch. Center punch has a few uses. Chiefly, it's, as the name suggests, for punching a hole. So you have used some of the other tools to mark out your location. Take your component. If you put it on the back of the closed vise here, the closed vise becomes an anvil. Simply find your point, and with a hammer, give it a knock. And you've got a nice indentation where we can either scribe circles or we can start drilling from that point. From there, we have these. They're called V-blocks. Very imaginative with namings, engineers. So V-blocks because they're V-shaped. V-blocks are used to keep round objects from rolling. Right. So this is a round object. And place it on there, clamp it in position, and I can work on the surface. You do get other V-blocks. I have a pair here. You can see the difference. These have clamps on them. The advantage of that is, yeah, it can be used this way and clamped down and worked on, but we can also use it upright if we need to work on this plane. Next thing we have here is an angle plate. This is an adjustable angle plate. You loosen the nuts here and it pivots, so it can go from, quite an obtuse angle right the way around. We get ones which are set at 45 and 30 and 90 degrees, but this is a fully adjustable one. Next, this is Scribe. Now, a scribe and the center punch are not to be confused. They both, they perform similar functions, but if you were to hammer on the back of this, you would just damage it. Need to be resharpened. It's a nuisance. So punch for punching, scribe for scribing. And it is used the same as a pencil, just for metal. So using a straight edge or your set square or anything, you can just mark on your material. Now got a straight line. Simple. So that's a scribe. You may be wondering what this is. I'm sort of doing everything on. This is called a surface plate. It's extremely heavy. It's made of granite. This is 450 by 300 millimeters, and it weighs 30 kilograms. So you can imagine a much bigger one will be almost impossible to move. If you were trying to move these and you dropped on your toe, regardless of if you're wearing safety boots or not, you're going to crush your toes. So please don't try and move them by yourself. That's why we're here. Technicians will help you, and that's fine. Yeah, so you get small ones at this size all the way up to pool table size. It's a surface plate. There we go. Now, it is a ground flat surface. This one's made of granite. You get them made from steel, ground steel. You also get glass ones. The advantage of the granite and the glass over the steel is that if it does get chipped, then the chip moves away and the rest of the table is still flat. If on steel you were to put an indentation in it, you'd form a little lump, and the plate would no longer be flat. To avoid this, no hammering or drilling is to take place on surface plates or surface tables. There are plenty other things we can do that on. These need to remain flat. Okay, the next thing we've got is a Vernier Protractor. This is a Vernier Protractor. It's much like a protractor in that it's for reading angles. It has a piece here, it's a blade, and it rotates. You have your scale. The Vernier scale, that's what it's named after. It will tell you whole degrees, but also tell you minutes of degrees. So you can measure to a much higher accuracy angles. The blades generally have a 60 and a 45 degree angle on the end as well, just for usefulness. Okay, next we have a scribing block. This is a scribing block. It's quite an old sort of, well, clearly it's quite old. It's an old technology. It's not used so regularly nowadays. There are other things I'll come to later. But using it's quite a sort of simple thing. If I needed, let's see. If I needed a mark scribed on a piece of material, what I would do, take my scribing block, twist it around, find the height I want to set. So that's 30 millimeters there. Lock it off. And I can now, that's not very tight. Make sure you tighten it. And I can now use this scribe to mark a line across my component. Like so. Perfect. Yeah, scribing block. The next thing is a combination set. As the name may suggest, it comes in several parts. It's a rule, but it's called a blade, and it's inserted into different parts. So let's see, the first one is this one. It's a square head, so we'll take that out of there and put it in here. That way around. Like so. And I now have 90 degrees here, 45 degrees here. Square head from the combination set. I also have a center head, which is the one it was in. So again, the blade will slide in, like so, hopefully. So, and with this, I can find the center on the end of a round object. So, I take my round object, placed on the V blocks, and with a scribe, mark a line down here. So, turn it about 90 degrees. In truth, it doesn't really matter how much you turn it. Mark another line. Where those lines intersect is going to be the center. Yeah, the more lines you do, the more accurate you're going to be. They should all cross at the same point, assuming the bar is round. So yeah, that's the center head. And the next one is a protractor head, as you may expect. Which way round is it? Yeah. This goes in here. And we can now measure angles with it. Right. Simple, simple. So yeah, I was saying earlier that the scribing block here is sort of starting to become obsolete. That's because of this guy. This is known as a Vernier height gauge. Again, Vernier, the name of the scale. We'll talk about reading the Vernier gauge, Vernier scale in a bit more detail later on. But you don't need to pre-measure because your scale is on here. So I find where I need to be, 30 millimeters, lock it off, take my component again, rest it against the perpendicular surface, and I can now use that to scribe my 30 millimeter line. It can also be used to measure height. In fact, its primary use is measuring height. So simply come down on top like so, lock it off. Now I have an adjuster screw here. So you lock the top one, adjust the nut until we're touching on top, lock up the bottom one, and now we can read the height, like so. Vernier height gauge. And the final one, second to final one I should say, I'm going to talk about is called Universal Surface Gauge. Quite a long name for quite a simple tool. If I have my cylinder and I want to scribe a circle around the end, I can use one of these. If I open it up, drop it down a little bit, doesn't really matter where. Obviously, you'd measure the height you need. There we go. I can now scribe a line around the end of a cylinder, like so. The final one, it's not on your worksheets, but it is definitely worth mentioning and useful, are these. They're called calipers, odd leg or Jenny calipers. Odd leg, it's pretty obvious why they're called that. The legs are odd. And the way these are used, they're another type of scribe. You measure the size you want. Let's go for that notorious 30 millimeters. There we go. And on the component, simply scribe across, like so. Now, you may notice this component is blue. Don't know if you can see that. Yeah, you can. It's covered in a dye. It's called marking blue. And the benefit of this is it's easier to see your scribing lines on a piece of metal. So just plain metal on the other side, blue on this side. Now if you're good, you can scribe, mark through the marking blue, but not scratch the metal. So at the end, when you're finished, you can wipe it all off and there are no marks. So that's what marking blue is for. The importance of marking out manually manufactured stuff should be pretty obvious. You need to know where you're cutting to, where you're putting your holes and things. I'm sure most of you have heard the old adage, measure twice, cut once. Probably better to measure 3 times. That's again, obvious reason. You want to save yourself as much work as possible. Engineering, I would say, is about being as lazy as possible. Finding easy ways to do things. That's what engineers do. Making everyone else's lives easier. And that is about all I have to say about your marking out equipment. Thanks very much.